Hello, good morning. It is now August 6th, I think, Tuesday of 2024. And I'm going to be talking about this circuit, and this is, can't remember what part it is, five or six, of that question about can solar cells or battery be made so they can provide more voltage and or current? Well, I'm going to show you they can provide more current by using a second voltage source that is equivalent to what the battery or solar cell provides, or the array of how many solar cells you're using, or how many batteries in a bank. Now, I have it connected to this 12-volt automotive bulb. And I'll turn it on in a moment and show you some measurements and go through this a bit. So, okay. I'll do that now. Just hold on here. There, okay. You can see the light bulb is on there. It's a 12-volt DC automotive bulb. And we'll make some current measurements here right away. Oh, okay, this would be the current going in from the black negative oh, is that right? Oh, I got it on volts. I'm sorry here. Hold on. I gotta put it on current. And DC. It shows about point. Let's say about 0.2. Well, that's what I had before. And now coming out to the light bulb should be this cord. And it says about 0.1. It's supposed to be more. What's going on here? Oh well. And here it says, oh yeah, here's a big difference here. 0.37 up to, well, it goes down a bit because I know the battery's draining. It was up to over 0.4 there. Okay, I'll turn her off and we'll talk about it. Let's disconnect this. Oh, he's snagging on something there. There. Okay. So, so some of that current is going into the little light bulb that I measured, and more of it is going into this capacitor. But what happens is some of it discharges back into the batteries, like it's charging it some more. So less has to come out of it. that makes any sense. But now here's the diagram, but I covered it with a nickel because that's the secret part of the circuit I don't want anyone to know about right now. And I've calculated with the battery by itself, it saves as much as 91.7%. And with the battery charger on, it measures 79.7%. And I think that's because the voltage is higher when the charger is on, because it's at 13.04 or higher. Gets higher as it charges. And the battery was just at 10.71 when I first started testing it. Oh, but this was with, these measurements were made when I had a 60-watt light bulb connected to it through this black cord. Then later I put the red light bulb on it. Now these measurements up here weren't quite as good. The most I could get out of it was 76.32%. I'm pretty sure that was with the charger off, and down here it's only 56.1%. Yeah. Yeah, it was 0.18 through the black wire negative and 0.29 going in the red. But altogether it was 0.41. So 29, 39, 4.7 altogether. And that capacitor is a 220 microfarad capacitor. Yeah, and here I would take 0.09 into 0.38. Okay, that's all I've got to say about that circuit. But what I'll be doing next is hooking up a 7 microfarad capacitor instead of this one here, which is 220 microfarads. And then this one here is 470 microfarads. And I'm going to see what those results are. And later, that blue object there is an inverter, which connects to a battery of 12 volts DC, and it puts out 120 volts AC. And I'm going to show you what it'll do if I'm successful. Okay, thank you very much for watching. Goodbye.